Hello ladies and gentlemen, and welcome back to another Jonah Central tutorial. Today I'm going to be showing you some more fancy functions. My 1000 subscriber video will be out soon, but first let's do a tutorial on some more cool graph stuff. So today I'm going to be playing around with something called the absolute value, which in a nutshell is basically on a graph, your line or wave or whatever cannot go under 0 on the y-axis, which can get you some pretty nifty graphs. So let's get right into it. So let's say I wanted to make a bouncing effect, for example. You know how a sine wave is kind of like an easing up and down, but that reaches a maximum of 1 and a minimum of -1? Well, imagine that we took everything that went below 0 and just mirrored it about the x-axis. Basically, that's what we're going to do. So, if I right-click this location for the z-axis, because I want to show you with like moving it on the z-axis, I'm going to go Add Driver. I just delete this variable because we don't need it. So, our replacement for x in Blender is going to be frame, and I like to divide it by 10 because frame on its own I find is way too high of a value. So I'm going to divide frame by 10. So to start off, let's just get our simple sine wave going. So sine, bracket, frame, divided by 10, closing bracket. If I press enter, as you can see, we have this cube going up and down on a simple sine wave, which is super neat. So if I go back to my driver, edit driver, I'm going to create a bracket at the beginning of sin, at the very end of the function, and right at the very beginning, I'm going to type down ABS for absolute value. So now, if I press play, as you can see, it's bouncing. And as you can see, the point right here, exactly in the middle, my point of origin, never goes under this like grid right here, because under this grid is negative on the location. And as absolute value works, nothing can ever go under 0. Now, of course, if you add like just subtract or whatever, or just move it around, whatever, you can obviously get different results. But just for basic functions, this will not go under 0 if you don't mess with anything else. Alright, so this is cool. Simple bouncing effect, but let's go a little bit deeper. So, inside of this absolute value function, I'm going to create a little multiplication symbol right here. I'm going to put the frame divided by 10 and sine in a bracket just to keep it isolated and keep my brain functioning normally. And I'm going to create 2 more brackets, and on the inside I'm going to do the reciprocal of frame divided by 10. So that would be 1 over bracket frame divided by 10 closing bracket, just because I want to keep frame in these brackets just so bed mass doesn't mess anything up. So if I press enter, now as we can see, the amplitude of my bounce is really, really small, but it starts off big. Now, it's such a small thing that it's kind of hard to see, and if you, in a practical situation, this isn't very good. So, what we're going to do is right at the very end here, I'm going to add a multiplication symbol, and I'm just going to multiply this by a value of 16, and this should increase the amplitude of the bouncing effect. So if I go back to frame 1, it starts off very high. This is because reciprocals of x, it literally comes from infinity at 0. Like, yeah, it literally does. And then it comes down, and it starts to smoothen out. So if you, on a graphing calculator, or you can go to Desmos, it's just an online graphing calculator, and you type in 1 over x, you'll get some really, really nifty results. And as you'll see, it goes to infinity. So that's why it starts off really big here, because we're basically multiplying infinity by a really, really small number. So, or I hope I'm getting this correct. So if I press play here, as we can see, it comes down and it bounces and it bounces, and its amplitude slowly starts shrinking. Now, it's not as smooth of a transition as I would have wanted. I'm sure there's a better function to kind of get that amplitude reduction. But for the time being, I feel like the reciprocal is the best I've got. And I did figure out how on a graph to also make it bounce faster as the amplitude gets less, like an actual object. The thing is, every time I've tried to put that in, it said it was an invalid Python expression. So I'm going to have to either find a way around it, or maybe it's just too complex of a function. But for now, this is the best I've got. But these are some pretty useful tools for some easy automation instead of painfully hand animating things. So thank you so much for listening. I really hope my math is correct. If I got anything wrong, please correct me in the comments, and I'll most likely redo this tutorial with more correct information. But anyways, thank you so much for watching, and I'll see you guys later.